Alright, so this is kind of the second video I'm doing about permutations. In this particular video, again, we're focusing only on permutations and investigating all the different scenarios of which a permutation would exist, such as the order is very important. And so we have to follow a certain order, or there's a reason why we have to pick these people in a particular place. So, common examples, again, running for a particular office, meaning president, vice president, secretary, whatever it happens to be. It might be positions on a basketball team or the batting order of a baseball team. But whatever it is, another big important fact about a permutation is I wouldn't want to repeat that option, right? So if you're on a baseball team, you can't have the same person bat 9 times. That's not fair. Same thing with a disc jockey, like a number 8. You have 250 songs. You wouldn't want to play the same song 250 times over, okay? Because that wouldn't make sense. So a permutation would be a situation where you don't want to repeat yourself. But we'll take a look there on number 14 to get some extra help. But anyway, let's look at number 8. I'll pick a few of these and we'll go over them. So, a radio disc jockey, DJ, has a library of 250 songs which he can choose from. And how many different ways can he program the next 2 songs? Okay, wow. So he has 250 choices to go from. Attaboy, DJ. But he only needs to pick 2, right? So 250 total possible outcomes, but the amount he really needs is 2. And you wouldn't want to repeat it, so that's why it's a permutation. So if I just simply type in the calculator 250, permutation 2, it's 62,250. So 62,250 unique ways I can play those 2 songs. Okay. Let's take a look at number 12. How many different batting orders are possible for 9 players in the baseball team? So as I mentioned just before, so on a baseball team, you wouldn't want to repeat the same batter, right? Like the rules of the game are you have to have all 9 players that are on the field bat and hit the ball, and then you start over. So the order of which the players go up is important because you can't repeat. So this is a great example of a permutation, okay? So on the batting order can only have 9 players. Now you may have like 12 people on your team, but remember, a batting order is there's some people that sit out, and there's only 9 players at a time that could be on the roster. So I have 9 possibilities, and again, the order is important because I can't repeat players, so it's a permutation. And how many different orders are possible for the 9 players? Okay, meaning I need to select all 9, right? I'm not just saying what are the possible that I can pick for 2 players. I need all of them. So 9 permutation 9, which is really just going to be 9 factorial, okay? Which is actually going to give me a huge number, which is 362,880. Okay? Or again, if you type in 9 permutation 9, you'll get the same answer. So in this case, we had to use all the players because, again, we have to fill out the whole batting order. Okay? And a lock is an obvious way, number 13, to use a permutation with 50 numbers. Again, it'd be 50 permutation 3 because I only need 3 numbers in the combo, but the order which I put in the number is important, right? I can't just like say, oh, I'll just do 1, 2, 3. What if the combination is 3, 1, 2, and that opens the lock? Even though you got all the same numbers, the order which you put in the numbers is important. But number 14 is what I want to focus on for the last problem here. So just like number 13, how many different combinations would be possible? The 3 numbers do not have to be different. So this is the first question in which we're introduced to, you know what? You can repeat. That's fine. So if that's a possibility, right, that changes everything, doesn't it? So if you can repeat the numbers, well, I have how many options? I have 50 options for combos, times. If I can repeat the number, then it would be times 50. If I can repeat the number, it would be times 50. So if it doesn't matter if I can repeat, right, normally on a combo lock it would be 50 times 49 times 48 because I can't repeat the number. But here, I can. So 50 to the 3rd power, so 50 times 50 times 50 gives me 125,000 different ways I can set up this lock. So those are all just a couple problems there. I hope these were helpful, but I hope you ask questions, and I hope these help.